Hi, everyone. Welcome to our mini training on using the Stormwater calculator, National Stormwater Calculator, and the SWMM model. We are doing this presentation today for the benefit of the student teams that have registered for the Campus RainWorks Challenge. Invited some of the EPA staff here just to be our live audience and to ask any sort of pertinent questions for our speaker today. Today, we're very happy to have Corinne Weisner-Friedman on to present and do the training. She's with the Water Infrastructure Division with the EPA's Office of Research and Development, and she is coming to us from Cincinnati, Ohio. So Corinne, why don't I just pass it over to you to take us through, and thank you again for doing this for all of us.
Yeah, this is super exciting. I always, I love being in like a teaching scenario. So this is fun, and also, I always learn some stuff too. So let me get started. I have a PowerPoint, and then we'll do some demos as well, and then mostly kind of focus on like the resources that people can use to learn more about these tools and to learn how to use the tools. So let me share my screen. Got it. Great. Okay. So let's just get right into it, I guess. Today I'll sort of give an introduction on the National Stormwater Calculator, and then we can do a demo using that. And then we will switch over to EPA's Stormwater Management Model. And then we will do a tiny demo, one that's already provided in SWMM, and I'll focus more on the resources that people can find to learn more about how to use that tool, because it's a little bit more complex. So EPA's National Stormwater Calculator is an on-site tool, so it estimates runoff on-site. It also provides access to national data sets like like weather data, temperature, and precipitation. And it provides some relative cost estimates for low-impact development controls. And additionally, it can provide some historical or future scenarios for runoff estimation. It uses EPA's Stormwater Management Model as the hydraulic model. It doesn't use all components of it, but it uses the ones that are most pertinent to like an on-site model. Considers soil properties, slope, land covers, and the low-impact development controls. So just so people become aware, there are lots of tools that are in sort of a toolkit available to look at green stormwater infrastructure. And there are some that are very sophisticated that do require a lot of education. SWMM, I would believe, is one of them. I believe it's totally possible to learn how to use it, that anyone can learn how to use it, but it does require a lot of time if you're going to do that. There's also VELMA, which is a water quality tool. And then there's as a more medium sophistication is Classic, and that's sort of a tool that's more at like a neighborhood scale rather than on-site. And it also provides some additional information like life cycle costs and additionally some multiple benefits. And EPA's Stormwater Calculator is actually what I would consider to be one of the most simple, accessible tools for GSI. And for that reason, I consider it to be a really great screening tool. So let me kind of just move on here and just talk a little bit about, why I consider it to be a screening tool. So engineers use this as a screening tool to look at a site for runoff estimates before they start building like a bigger, more complex model with something like SWMM. LEED uses this tool as sort of part of the first step in their in a 4-step framework to get LEED certification, which includes getting points for stormwater management. And that first step is just basically using the output of this tool for their site. The second step is building a more designed version, like engineered version, then implementing that, and the last step is monitoring of that. So additionally, individuals, cities, groups do use this tool for grant applications, usually as part of their first step in like that application process. And additionally, We get other people who are just interested in doing things on their homes or kind of just making personal decisions about what to do with their stormwater using this tool. From August 18th, 23 to August 18th, 2024, we had 186,000 site visits. And most of that were not EPA people. So we do have a lot of wide usership of this tool. Let's just get into the components, and I'll try to get through this pretty quickly because we'll just see it all again when we actually do the demonstration. So you'll input your location, and you can, at your location, you can draw a polygon around your location, or you can define a radius using a number of acres. Because this is an on-site tool and it's not spatially explicit, this is just going to take an area. So you might use the polygon tool in the map to help define the area associated with your site if you're unsure of the area of it. But otherwise, there's no difference between those two things in terms of the calculations. So then we'll have data coming from Surgo, which is a soil survey, and that's going to include the soil type, the soil drainage, and additionally, even the topography. And then we also have precipitation and temperature information that is coming from NOAA and other sources. And this says that it's been recently updated as of 2022. And now we're sort of getting to a point where we need to update that again. So that'll be coming in the future. Then there is a future scenarios module where we can look at, so this is the future scenarios module with this little earth here. And that will account for changes in monthly average temperature based on some existing tools. And then we also have land cover in here, and that will sort of affect how, the sort of, if you guys are familiar with Mannings and all and things like that, it'll sort of affect that. And then we have our low impact development controls. And so let's go into greater detail on those. So among the low impact development controls that we have available, we have disconnection, rain harvesting, rain gardens, green roofs, street planters, and infiltration basins. And all of these tools are going to basically help collect runoff from impervious surfaces and help to retain it on site. So some of these are more pertinent to certain regions than others. I think that there are some rules around rain harvesting that if you're out in the West, you might need to look into that. So do look into your own local laws and stuff about water retention so that you know that what you're doing is good. So anyway, how it works, generally speaking, is that it's going to address surface runoff, infiltration. It will also address groundwater, snowmelt, stormwater detention, and it will, it does not include all these things. So it will only include a certain subset of those things that SWM accounts for. So I'm a little bit just kind of getting up this morning, I guess, waking up to our being in person. So basically, stormwater calculator will use the site area, the width of the outflow face, which is a very important measurement in SWM, the percent imperviousness and the depression storage depth, the roughness coefficient, which does vary by land cover, and the percent of impervious area without depression storage. So it's basically just a subset of the functions that SWM can use. So that's why I kind of say that it's a good screening tool. It's not going to be as precise as you can be with SWM. All right. So here's sort of the general processes that are accounted for in the model of like a street planter. So it includes run-on, evapotranspiration, rainfall, infiltration, percolation, and also infiltration and overflow and also underdrain. So it is accounting for many processes. So it is quite nice. And we can kind of go ahead and just look at how we would use the stormwater calculator, in my opinion, as like a screening tool to accomplish the goal of retaining more water on site. So let me just go to our tool here. And before we start here, are there any questions in terms of just the introduction of the tool?
Corinne, I
Okay.
just have a quick question about, like, is it possible to use the two together if the students want to be sort of very ambitious and use
Yes,
a
I
screening
think
and
that would be strongly advisable. I think that together that they're a really great combo. So if I were in this challenge, what I would do is I would use the stormwater calculator to kind of look at different kind of toggle different ways of implementing LIDs for a particular site, or maybe even comparing between a couple sites, and kind of just getting a feel of what you want to do, and then go into SWM and try to design it out a little bit more thoroughly for a particular site. So I can kind of show you, how you might compare site stuff between these two, and also how you might compare different LID implementations in this. And that would be something you might want to do before going into SWM or some other more engineering based stormwater modeling. And then Robin, did you have your hand up as well?
Yeah, I was just curious about like if somebody was on a campus and had that'd be helpful when you show your site how you could incorporate a campus style location.
Okay.
I
Yeah,
know it's
maybe
not like
does
one
anyone
parcel.
have an alma mater here that they want to throw out there that we could go zoom into for this example?
well, mine's
I mean,
Berkeley.
yeah,
Berkeley?
Berkeley. How about Berkeley?
All right. So I guess I need like an address, huh?
Oh,
Let's just see. I guess we can Google it. So 110, I'll just all right. And we'll just call this Berkeley. All right. So we can enter in our site address. So I'm just going to paste it from what we have there and press enter. And this brings me to Berkeley's campus. And what we can do here is you'll see that I can move up and down and all around. And I can also change what layer is sort of displayed here. So if you want, you can see an aerial view that provides maybe more information about the imperviousness, if that's something you need to do. So let's see. We got to find a good place for our site, right? So let's try to see. We want to find a place where there's lots of imperviousness potentially, right?
that would probably be Sproul Hall there, where the
Yeah, right
address
here.
is. Yeah,
All
that's
right.
right where Sathergate is located.
Okay. So, oops. Let me just go way back over to Sproul Hall. Sorry. This is fun. It's like visiting Berkeley. All right. So now that we're nice and zoomed in here, you can decide to, if you have a site selected, so right here, if we select this site, you can assign, a certain number of acres for your site. And that can go up to 12 acres. And it only goes up to 12 acres because it's an on-site model. Again, it's not accounting for all of the routing that SWM would account for. So after it gets to be too large of an area, the model does start breaking down from being just an on-site model. So It is limited to 12 acres. If we click on this polygon, we can start outlining an area that we're interested in. So maybe we want to focus on sort of this area, maybe over here, just kind of in front of this building. And we can just sort of draw a little polygon around it. Let's see. Oops, sorry. You know what? Because the computer is so slow today, I'm just kind of, sometimes when I click things, it's a little bit off. But there we go. And then you just close it up. And it looks like our acres are 2.58. So that's pretty good. It's actually smaller than I would have thought, but okay. So now we can go to our soil data. Sometimes this database is unavailable, and I'm looking to update it soon to something a little bit better. But for now, it does appear that it is available right now and that there's quite a lot of data here, which is great. It looks like there's high clay in this area, so we're going to select that. I would guess if I were to interpolate between this spot and this spot, it would be high clay, but maybe, you know, a student might have the capacity to test the soil that they have for their particular site. And I think that would probably be a smart thing to do. So now we can look at the soil drainage. So this is something else that you might be able to test for, soil conductivity. Here we can see that most of this is purple. So if we look at our legend here, in purple, we're going to have that it's greater than 0.1 to less than or equal to 1 inches per hour. So let's set hours to something kind of in the middle. So let's just set hours to maybe like 0.5 or something. And then we'll go to our next option, which is the topography. And the pink here indicates that this is moderately flat, or no, that it's moderately flat. Now, you might have local knowledge because you're on the site and you can go visit the site. So, Clark, do you remember if this site is moderately flat or very flat or something like that?
That side is very flat.
All right, great. Okay, and then we'll go to our precipitation and temperature data. So we see that right here is our nearest station. So we're going to just select that station for this purposes. And something that's important to note here is that you can actually download the precipitation data and the temperature data. And when you do that, they will be downloaded in .dat files. And those are something that you can then directly use in SWM when you're building a SWM model later. So this is actually a really great source of data for when you're doing a SWM model. All right, so we'll go to our future scenarios model. And we're going to select that we are not concerned about future scenarios. So we're going to select no change here. And now we can go to land cover. So this is where the having that aerial imagery can be helpful from you know, perspective of calculating things. You can also, if you want to be more precise, go into ArcGIS and actually make polygons and measure things out so you have a, you know, a better estimate of the percentages that you're associating with these different land covers. But basically any building that you have, anywhere where a drop falls and it has to run somewhere else, is going to be impervious. So on the building here, and all of this here, and all of that there looks to me to be impervious, with maybe some additional sidewalks around the building. So, I mean, that kind of looks like, if I'm all eyeballing it, it looks probably about like 60% impervious, maybe 65% impervious, which is already here. We're just going to decrease the lawn here to 35%. and that will automatically set this up at 65%. You can select forest. There's not really forest here. There are some trees, but I wouldn't really qualify it as forest. You can select meadow or desert. So this is a scenario where you have like already the developed scenario. Now, as an alternative, something that could be interesting is if you're interested in trying to retain water on site, as if it were like the natural hydrology, you can try to consider what land cover would this have had if there were no buildings here. Now, I don't know much about California, but I feel like it's supposed to be a desert, right? Or is it not?
It's a Mediterranean climate, so
maybe some forest, maybe some meadow.
yeah, and like chaparral,
Okay.
grasslands probably. Yeah, it was probably
Okay.
grasslands in this area.
So maybe like a meadow type of setting might be good. So if you wanted to, instead of doing lawn, you could switch out with some combination of forest and meadow that you thought was appropriate and see, how you can compare this particular developed scenario to a natural hydrology scenario. But for the purpose of this shorter training, well, we won't go there. That's just something for you to consider. And I'll just point out that if for some reason you're really confused about what these mean, there are some very simple pictures and descriptions under each of these. I find them silly, but maybe they're helpful to some people. So that's just a note. All right, and then we're not going to go to the LID controls quite yet. We'll come back to those in a minute. And the project cost is going to be associated with the LID controls. So we'll also skip this for the moment. And we're going to go to results. So right now you'll see that there are no results. You're going to have to press refresh results. So if you have more years to analyze, it will take longer to run this. For the purpose of our presentation, I'll just set it to 1 year just so it goes quickly and smoothly. But LEED and lots of other types of of these utilities that want you to use this as a first screening school will require 10 or 20 years to analyze. So yeah, and the event threshold, that's basically saying what qualifies as precipitation. And here it's saying 0.1, anything that's greater than 0.1 inches is going to be qualified as precipitation. And you can like check on your phone next time it's kind of drizzling outside. You can see that when it's kind of drizzling outside, you're actually above an estimate of 0.1 inches for that hour. But when it's kind of cloudy out, sometimes you can be at an estimate of 0.1. So that's just for your own note. Most people will set this at 0.1. All right, so now we can click refresh results.
Hey, Corinne, while we wait for the result, I was curious, what do you mean by threshold? Event threshold? Is that like the minimum amount of
So when it says here days per year with rainfall, it's going to be saying that it's only going to count days where there was greater than 0.1 inches as days with rainfall.
Okay, thanks.
Okay, so here we have sort of our summary results, and we can see that there is more runoff than anything else. And so our goal is to try to reduce this runoff. And there are lots of other helpful reports here. And if you need to see what they mean in greater detail, you simply can go to the resources and click on the user guide. And in the user guide, there are very clear descriptions of each one of those reports that can be helpful. I'm working in the next release to have info buttons so that it's directly displayed in the website so that you won't have to go do this little dance around. But there are also other information sheets here that are really helpful if you need to access them. So just keep an eye out on these. Let's just see, for example, if we're looking at rainfall retention frequency, we can see that for each daily rainfall event, that you can see the percent of the time that that rainfall event is retained on site. So here's our current scenario, and we can see that for small rainfall events, it's very often retained on site. And for larger rainfall events, it becomes retained on site less often. So if you wanted to compare this to natural site hydrology, so let's just go, so actually let's click on, use this as baseline scenario. So now our development scenarios are baseline scenario. And we can go back to our land cover and we can do what I was sort of talking about before. So let's say that this is mostly meadow and like a little bit of forest. Okay. We can go back to our results. It'll say, oh, the site data has changed. That's because we changed it. And now we can refresh our results. And now you can see that in the current scenario where we had the natural site hydrology, the rainfall is always retained on site. So that's something that, you know, that would be a very ambitious goal to always retain stuff on site. So let's go back and we'll return to our development scenario where we were at 35%, or sorry, 65% lawn. No, we were 35% lawn, right? Yeah. All right, and now we can start looking at some LIDs. So if for some reason you wanted to save the current results, you know, you can always click save and you'll be able to download those results immediately and just keep that data. So you could call it Berkeley and then you can describe it a little bit and then you'll be able to open those results back up later to compare. But for now, let's go to the LIDs and we'll now define a new current scenario where we're going to have our development scenario with LIDs. So in this region, I don't think disconnection is pertinent, so let's just ignore that. Let's think about some rain gardens. So if you click on rain gardens, you'll be able to see that they have a description here. If you want to learn more about rain gardens, we have a design manual that you can use. But here you can also set some other parameters. So you can set the ponding height, the soil media thickness, the soil media conductivity, and the percent capture ratio. So the percent capture ratio is like how much of that, or how much of the runoff from the impervious surfaces are being captured there. And for the soil media conductivity, these are sort of, and the soil media thickness and ponding out, these are sort of average values that are already sort of defaulted in here, but you can switch them if you like. You can also, if you know the design storm for your area, which you can obtain actually by going to extreme event runoff, wait, by rainfall percentile. There we go. So if you look at like a 95th percentile event, that corresponds with a rainfall depth of 0.97 inches. So if we wanted to size our rain garden for that event, we can just put in 0.97 inches. Go to rain gardens. And then size for design storm. And it increases the capture ratio by a little bit, basically, is what happened there. So we can save and return. And now we're going to say, let's look at our site in closer detail and try to think about where we would put this. So this is where, you know, you want to be able to know the site really well and know where things might be going. So, you know, it's possible that anything that lands on this here is maybe collected by a gutter somewhere there. But that maybe what lands here might go over here, or what lands here might go here. So you really have to get to know the site. So let's pretend that we know the site and we think that what lands over in this spot here goes to this area here. So let's try to think about what percent of the imperviousness this is. So of the 65% imperviousness that we have, what percent of that is this part? So maybe like an eighth. So maybe, what is an eighth? Like 15%. So let's say that our rain garden is going to capture the runoff coming from the 15% of our impervious surfaces here. All right. Now, let's say that because all of this area here is maybe something where the water is flowing into a gutter or it's coming over a different way. We can't really put a rain garden there. Maybe let's say, well, let's try to put in some permeable pavement. So maybe we'll put some permeable pavement in this square here. So in that square there, let's say that that's another, well, I guess let's just turn this to 10%. That seems more right to me. I don't know why. So let's do some permeable pavement and do another 10%. We can also look at the parameters in our permeable pavement, and we can also size for the design storm. So now we have that set. Let's go and run this and see how it's changed our baseline scenario in terms of runoff and other things. So let's go to our summary results again. And we will now click refresh results. Okay. So average annual runoff in inches is now at 8.58 from 10.61. And we can look at, because we've become familiar with that other plot, let's go there. And we can see that now in our current scenario, water is being retained on site more often for larger precipitation events. So that's great. So, you know, from here, maybe we can say, well, you know, maybe, you know, we want to size for a different design storm, or maybe we want to see about some, you know, some cisterns for the building. So let's go back to our LID control and see what else we can add here. So let's say that this building accounts for 30% of the impervious surfaces here. So let's do 30%. And let's look over here. So here are our parameters: cistern size, emptying rate, and number per 1,000 square feet. So let's size for our design storm. It's quite a lot. And then we will save. Now, I think also you can change, you know, if you want a larger cistern or a faster emptying rate, that will also allow for less of these, but let's sort of just leave this as is. All right, so let's return here. And now we can go back. It says that our site data has changed. Again, if we want to say, if we had wanted to save that scenario before we rerun this, you quickly, you know, you'll want to click save before you change anything. But let's go back and let's see what happens now with our new addition of a cistern. So that's looking very impressive. So now let's go see our rainfall retention frequency. Wow, that looks pretty cool. So anyway, so here you can basically kind of just toggle through different options. You can go to this cost summary. Now, right now it has our site suitability as poor, but that means that it's hard to get to and not really easy to develop. So let's actually change this as a excellent site suitability. And we're going to go back here, and it's going to tell us that we have to refresh our results again. No problem. You don't have to do that if you go through the first time around and actually do this module with everything, but we can look at our cost summary. And what I'll warn you of is that I find these numbers to be very inflated. There's some costing information out there available through other resources that I believe to be probably more reliable than this. So what I would do is kind of compare the scenarios. Like if you have two different LID scenarios, I would compare them in cost rather than trying to so like for the, so one of the reasons I don't necessarily believe this is because the baseline scenario has costs associated with the stormwater infrastructure for one, and those are not represented here. And two, I find that some things just appear to be a lot more expensive than I think that they really are. I don't think that the permeable pavement, that looks realistic to me. The rainwater harvesting looks on the high end to me because there are different ways of doing that, and where you source your materials from and how DIY you want to get can change those numbers. So yeah, so I would just use these as sort of like, just to compare between LID scenarios and sort of see what those are. But I would probably seek, some advice from other sources in terms of cost. And I think that Robin DeYoung and others have provided some other resources on that front elsewhere. So that's just a note. Anyway, all of the other precipitation and runoff estimates are pretty great here. So I would stick with those. So anyway, that's sort of just a overview of this tool. Again, if you have any questions ever, you can feel free to contact me. If you click this button, it'll send me an email, swc@epa.gov. And one last thing I just wanted to point out was that in all of these little modules, there are extra resources. So please do dig into those resources. They could be very helpful. So let's return to our PowerPoint presentation unless there are questions. Okay, go back to PowerPoint. All right. So let's move on to the stormwater management model. So this is public domain software. Oh, there's a typo there I missed. For modeling rainfall runoff processes in urban areas, primarily, though it has been expanded to other areas before. And it is used widely for planning analysis and design of stormwater runoff networks and sewers. I still need to figure out the source of this citation, but at one point someone told me, I think that something like 70% of utilities use SWM for their stormwater and sewer management networks. And the first version was released in 1971, and we are currently on version 5.2.4. So it is used for the design and sizing of drainage system components, the control of combined and sanitary sewer overflows, modeling inflow and infiltration into sanitary sewer systems, and generating non-point source pollutant loadings for load allocation studies, as well as evaluating green infrastructure for sustainability goals. So there's a lot. So the simulations that you can run in SWM can be based off of single events or kind of like design storms or continuous events. So if you have a bunch of historical data, you can do hydraulics and routing. There's two options in SWM. There's kinematic wave and dynamic wave. Kinematic wave is a little simpler, but will run faster. Dynamic wave is more precise and complex. And also a little bit slower, but worth it probably. Water quality modeling that it does is some pollutant buildup and wash off and treatment and conveyance systems. There's a lot of work to be done with the water quality modeling, but I do believe that it does some limited pollutants well. So I just wanted to provide some basic model examples. So essentially there are these different components in the SWMM model. So there are subcatchment areas, and those are representations of land surfaces where rainfall falls and then is captured, infiltrated, or routed. And in these subcatchment areas, you can define the percent imperviousness, and you can define other qualities associated with the land cover. There are nodes and junctions. So that would be, so this center node for this catchment, that's a node for this catchment. And it connects here to this node that connects to some conduits. And so those are basically just connection points within the whole drainage network. There are links, and those include conduits, channels, and pipes. So that's basically just where water and pollutants would flow. And then there are outfalls. So that's going to be points of discharge from the system. So, you know, if this was a, you know, there was like a wastewater treatment plant and then there was an outfall from there, for example. And then there's also low impact development controls and nature-based solutions also available in SWMM. So there are some data requirements. So you need historical or design storm events for rainfall data. You might need some land use and topography. Those can be helpful, like digital elevation models, slope and area and imperviousness. So in SWMM, when you draw a box, it's not going to completely correspond with an area. You have to set the area. Then there's soil and infiltration parameters. So that information, you know, you can get, you know, for a site, again, possibly from looking at Stormwater Calculator, or there are other places you can get it from, which we'll talk about in a bit. So, and then you also need sort of the system geometry and the hydraulic structures, pipe channels, storage units, weirs, and orifices. So, you know, let's say that you're working under the assumption that maybe a campus site has some under drainage somewhere going into another drainage system where you have a stormwater drain or a stormwater pipe system. And so knowing where those structures are could be really useful to understanding how what your improvements are going to do. All right, so then I'll talk very briefly about how to build a simple model, and then I'll show you where you can find SWMM and kind of just get you started on it, and then provide you some resources that will get you a lot further into using it because 30 minutes is not enough time to show you how to use SWMM. So essentially, the steps to build a very simple model in SWMM are to define study area boundaries. So you can determine the subcatchment size and the catchment delineation. You might go into something like ArcGIS, ArcMap Pro, and you might export your map, a base map, with a world file, and then you can upload that into SWMM and use that to sort of help you delineate things and determine, you know, where you're going to be putting things. And then you can enter in hydrologic parameters, so the percent imperviousness, infiltration, and other parameters that exist in SWMM that you can learn a lot about. You can set up your hydraulic network. So how are things going to be routed through this area? So defining your nodes and your conduits and outfalls. And then you can add time series data. So you can add rainfall data. You can also add temperature data. And if you have like evaporation, that should be included in there. You can potentially add, and if you have collected flow data, you can add that in, and you can then plot side by side your flow data with your modeled flows to sort of check on how your model is working. Strongly advisable. And you can also configure simulation options. So increasing time steps, you know, are going to allow for more refinement, but might take, if you decrease the time steps, it will allow for more refinement, but will increase the time that it takes to run. You can use continuous or design storm for your rain gauge situation. And lastly, you'll have to check how the model is running. So making sure that at the end when it's finishing, it's, let's say, like runoff error and routing error, and those should be around 0. Otherwise, it means that you have some issues in your model. If, for example, the flow routing error is very large, then it means that there's somehow, I guess, more going in than you think. And if it's negative, very negatively, very negative, it means that there's more going out than you think. So there's a lot to learn on this front, and there are a lot of really great resources to help you learn about those things. And I'm still a SWM learner, I think. So I utilize at least OpenSWM quite frequently. So basically, I'll just sort of give some examples of some of the more advanced features, and those are the dynamic wave routing, which are going to produce more accurate hydraulic analysis. There's real-time controls, which you can do in conjunction with using some other tools, where you can simulate gates, orifices, and pumps with control rules. You can use control rules in SWM itself without going anywhere else. You can use control rules in SWM. And then there's water quality and low impact development modeling, which helps you to evaluate pollution concentration changes across catchments. And then there's you can do some model calibration and validation as well. So those are just some advanced things that you might consider. And then so we'll get to our resources here. So I'll just sort of briefly outline these, and then we'll go look at them. So for soil infiltration data, there's the Surgo stuff, which is available in the Stormwater calculator. My new favorite thing that I'm trying to get into is the gridded national soil stuff. So this is basically someone who, or people who have interpolated and also drawn from different data sources to create a gridded soil data set that might be a little bit more precise and spatially explicit than what is available through Surgo. There's the land use and land cover data set, which will allow you to get a good sense of what the land cover is without you having to go there, which you should be there. So I don't know how relevant this one might be. There's historical weather data. Like I said, you can download that straight from the Stormwater calculator, formatted exactly as you need for SWM. There's site configuration. For that, you can use a lot of GIS tools. So if you're trying to determine the percent imperviousness, you might want to just do some calculations in ArcGIS, for example, as one potential GIS tool that you could use. And there's a lot of help that you can get. There's the SWM user manuals are excellent. OpenSWM is fantastic, and you'll often come across a lot of questions that you are asking already answered. And then I recently learned about the University of Texas at Austin has a SWM PowerPoint course. So let's just go ahead and look at some of these resources. So first of all, if you go to EPA's website, you can find the Stormwater Management Model landing page. And here you can find where you can extract the 32-bit or the 62-bit version of SWM. And there's also here all of the manuals. So there's the hydrology manual, the hydraulics manual, and the water quality manual. So if you want to now, go ahead, and if anyone here is interested in downloading this, you can go ahead and do that now, while I'm sort of generally just kind of walking you through these other sites. So there's the Surgo database, and there are certain mapping products available through the USDA and other places, but you can also just obtain this data from the Stormwater calculator. Other data products that could be interesting to explore if you're doing like a larger project, maybe like a cross-campus project, for example. I don't know how that would work, but you could use GNATSCO, And this is one that's taking from StatsGo2, also raster soil survey and Surgo, and then creating a gridded version of soil properties. So that's pretty cool stuff. I'm just going to move this down because it's the part where it's sharing my screen. There's the National Land Cover Database, which we talked about, and you can download the data pretty easily to multiple different format types. And then here's OpenSWM. So let me just show you OpenSWM briefly here. So people have shared their research, which is great. You can also look at the SWM code if you're trying to understand the processes involved a little bit better from like a coding standpoint. It might be easy if that's how your brain works to understand it from here. And you can also just sort of share information and knowledge and ask questions. So, you know, let's say that let's see actually if anyone's posted on here from Campus RainWorks. I don't actually know if they have. Make a tradition of it. Nope. So let's see if someone has a campus in their in their search, in their wording here. So lots of lots of articles with the word campus in them. You might find something interesting in here in terms of like pertinent things to think about when thinking about stormwater drainage for campus. But let's actually think about some low impact development controls. Let's actually see if someone has maybe even shared like an input file. There's no input file here, but I do know that you can find example input files on OpenSWM. So, you know, you can kind of just search and so example input. So some people have example input files here. So if you just want an example of those, but luckily you don't actually have to look here for example input files because SWM already includes some. So we'll look at those in just a moment. But this is a great place if you want to ask very specific questions. If you're saying, you know, oh, something is wrong with my model, then you can even post it here and someone will probably answer you pretty quickly. There are a few common names that come up here that are very knowledgeable people who contribute a lot. So here's the SWM PowerPoint course. So you can look at this. It looks like they're PowerPoints for everything up until just kind of like down to very simple things up until let's see. Sorry, my computer is insanely slow today. Looks like those are the only ones available, but it looks like these are the very basics of SWM. So those will help you to understand what each of these things are in a very introductory way. So that should be really great for people who are just getting started. And so lastly, let me go to SWM. And so when you download SWM, eventually you'll be able to pull it up. Sorry, my computer is so slow. Just stop sharing and reshare. All right. So when you open up SWM, you'll see this screen here, and you won't be able to do anything until you either X out of it or you click something here. So Here are your recent projects. So you might not have anything here, but here you'll have some sample projects. So, you can look at site runoff drainage, detention pond design, low impact development. So that should be interesting. But before even those sample projects, you can look at the basic tutorial. And this is a really wonderfully written tutorial that allows you to get started with everything here. So they basically walk you through a scenario where you have 3 subcatchments and you have a series of nodes and conduits that lead to an outfall. And it'll walk you through all of the different things, that all the different parameters that are sort of the basic parameters of those components. So I recommend doing that tutorial. And lastly, let's just look at the LID. So let me just X out of that again. Or actually, I can just bring up another one. All right, so we can go to sample projects, low impact development. And at the bottom, you'll see openswim.org examples, which is cool. Oops. So it does bring up some text about the model. I'm so sorry, you guys, my computer is just rough today. So this example illustrates how LID modeling feature works. So this is a data file representing a 29-acre mixed-use subdivision. So that's much bigger than our Berkeley example. And it says that we're considering rain barrels, infiltration trench, street planters, permeable pavement, vegetative swales, and so that's quite extensive. And yeah, and then there's some questions, there's some sort of verifications here. So how we're determining that the low impact development usage has a reducing runoff effect. So, and that's basically, these are some steps to go through. So here you can see that there are catchments defined. You can see that they used a background here that sort of represents their sites. And you can kind of click through and see sort of what each of those things are. So I'm saying that this is a subcatchment swale 3. And the rain gauge is rain gauge. So if you go to rain gauges, you'll see like the rain gauges here. This is a time series rain gauge. So that means that the time series associated with this 2-year event. That 2-year event is documented here in these times and values. And that is connected to this other one here, S3, also associated with that rain gauge. You can see some of the other properties or parameters that are listed here. It says that it has no groundwater influence. It's saying that there's the percent imperviousness of 39.5% indicates the slope. You can see that they have associated coordinates here. And so that's something that you can consider including, and that will map things onto this sort of visual. And yeah, I guess so what I would recommend is looking at those other resources and pulling up an example and clicking through and trying to figure out what you do and don't know. So if you clicked rain gauge and you said, oh, rain format intensity. Oh, there's 3 options. Okay, well, what do these actually mean? Or time interval, what's that associated with, right? So, basically what you'd find out here by Googling or looking in OpenSWIM or learning from other resources is that this time interval is what's associated with this time series. And that, that you have rainfall intensity, which is basically saying that you have like a sort of like a design sort of situation. And if you look at, let's see, another thing that we can maybe click on for fun. We can click on one of these little outfall. There we go. Okay. So inflows. Oh, what does that mean? So that means, let's see what happens if we click on this. We have our direct dry weather, or we also have inflow and infiltration. Well, that doesn't seem pertinent to our situation here. So great, we don't need that. But so these are just sort of things that you might want to click through and try to learn about as best as you can. So yeah, there's not too much that we can get into in half an hour, but I feel like this will provide a good baseline of information for everyone to be able to access the resources that they need. So let me just share my screen one last time. So that you guys can write down my contact information if you would like to ask any questions.
While Corinne is switching over, does anyone from our EPA here have any questions for Corinne or clarifications? Well, if not, I will say thank you very much, Corinne. I anticipate you might be getting some emails in the next couple months. So I think that would be a great chance for you to sort of maybe give a little one-on-one to some of the teams who may be contacting you. But again, thank you so much for taking the time to run us through these two models. There is a question from Prasad.
Go ahead.
This is just well, first off, thank you. That was really helpful. I have played around with that tool, and this was awesome. It was really awesome. This is just a suggestion for anyone else that when I was using the tool, because of all the data and my, at the time, Wi-Fi connection, it just took a long time to process. So I was doing it at a state partner and using their building as the option. So it would have been better for me to have like run this scenario before the actual demo. And that way I could have showed like PDFs in case it's when it slowed down. So just for anyone else that's doing demos with that calculator, it's really a helpful tool, but just to prep that way. And I'm talking about the stormwater calculator specifically.
Thanks, Prasad. That's helpful to remind people. I've run into that before with running tools live.
And then Stacy in Denver asks, how do you think Classic compares to the tools that you've demonstrated? So where does that fall into the taxonomy of tools?
Sorry, was that directed towards me?
Oh, yeah, that was directed towards you.
Sorry.
Yeah.
I thought that you had mentioned someone else's name.
Well, it was
yeah,
Stacy.
Classic has more capabilities than the Stormwater calculator, but it's less refined for an on-site sort of scenario for rainfall calculations in particular. So in terms of runoff calculation, I think that for a 12-acre or less site, the Stormwater calculator is definitely preferable. However, if you want to evaluate sort of like a larger scale, or if you want to evaluate things in terms of multiple benefits, gray infrastructure even, and life cycle costs, then like life cycle analysis, then I think that you would want to probably go with Classic. I've not used Classic. I've just looked a lot at its documentation. So that's something that I could probably look at in the future, trying to get that as a, dig deeper into it to be able to speak more to it. But from what I have seen, it does require a little bit more training than Stormwater Calculator, but probably less training than is needed for SWM. So I think anyone who is doing this challenge can definitely handle using Classic if they want to use that as a supplement to this, or if they want to use it instead of Stormwater Calculator.
And what about the cost data that's used in Classic?
You know what? I don't know where that's actually sourced from. I know that the Stormwater Calculator was the costing data comes from the Bureau of Labor Statistics, and also just by kind of going into the different supplies that you would need for different projects and kind of scaling them in sort of a regression type way. But there are available for, I think actually, let me just find, there's one that I think is called IDST. That's in the integrated support, or it's through the Colorado School of Mines, and they got, I think, an EPA grant to create this tool. Let's see. So it looks like it's still available, but this is oops. I'm not allowed to look at that. But that's a tool that should be, it's one of EPA's, it's among the green infrastructure toolkit that we have, this is actually a really great resource. So let's just go here. So you can see that among all of these, there are, so SWM is mentioned, Stormwater Calculator, GIWiz, I don't know what this one is, Velma, GIFMod, Classic, and then IDST. So IDST does do ancillary benefits, and also does life cycle cost assessment. So that's something that you can look at there. And then for Classic, it does understand, it weighs the estimated costs, but yeah, if you were to go to the information, you would probably be able to find a user manual that would detail where the costing information is coming from.
And I will say to the teams who are, the campus teams who are listening in now, this is where it's going to be very important for you to talk to your facilities folks, as we really highly require and recommend, because they're going to have sort of first line data on some of the costing that they are using currently on your respective campuses. So that might be like a really good source and good question to ask in your meetings with your facilities folks.
Yeah, and I think something again that the Stormwater Calculator does not do is it does not really indicate, well, without this infrastructure, what are going to be the costs? And there may be ways to figure out what are the costs that you're dealing with because you don't have enough stormwater infrastructure. So that's, I think, a really good question to ask. So anyway, that's all I have, unless anyone else has more questions.
Anything else, folks?
Yeah, I had just another question about so if you're wanting to use SWM, what would you suggest people should do to gather data ahead of time before downloading the tool and starting to play around with it? Is there, like, could you talk about that?
Yeah, I mean, I think you can definitely download the tool and play around with it before you have any data. And actually, I would recommend doing that before you have data. But what you will need for your site is, I mean, you can use very little information. You can use a lot of information. But as I mentioned, you probably want to have some sense of where the water is going to flow. And so you're gonna probably want to assign, elevations at some point, and how you assign those elevations can be based off of either maybe there's a product out there like a digital elevation model, which, depending upon the size of your site, it might not be refined enough for your site. What you could also do is go out and measure things. And I, being someone who's both a modeler and a field person, I am a strong advocate for just you go out and you measure what you need to measure. So if you have to go to your site and let's say you don't even have what you need to measure elevation, let's get a bucket of water and pour it somewhere and, see where it goes, and, or ask the facilities people, where, how things seem to work, or wait for a rainy day and you can try to figure out, where things are going. Use all your tools that you have available to you, including being actually on site and looking at the things that you need to look at. And, there is, nuance to stuff too, right? Where you might have one day where there are really heavy flows. Things might flow a particular way and might look one way, and then you might have a different day where, they'll probably still flow the same way, but it might look a little different just because of how things might be pooling or, other things like that. So it's important to consider that different days are going to look different. And so there is a lot of good reason to use a continuous simulation in SWM, for example, to help better understand that, those sort of ideas, but that you can always sort of use sort of your baseline knowledge, go to the site, try to figure out where things are, where they go, what things are made of, and talking to the facilities people, what's underneath is also a really important question. So I think that in this presentation, you can, I guess since it'll be recorded, you can zoom back and try to look at those resources that I provided for, the precipitation, the land cover data, and the soil infiltration stuff. But, again, if you have access to a lab where you can measure soil conductivity, like that would be a really, really cool thing to do. So just I guess my advice is use all of the data available online that you can to your best capability, and also, get like into the field and look at what you have and see if things are actually matching up with what you're seeing from those products.
Thanks.
Yeah, that's good advice, because obviously the students are going to be working on their own campus or an adjacent schoolyard campus, so they should have easy access to get out there and check out the real conditions on the site. So again, one last call for questions. Looks like we're good. So again, Corinne, thank you very much for the time.
Thanks for having me, and I look forward to questions from students, so that'll be fun. All right.
Great.
Thank you.
Okay.
All right.
Bye-bye, everyone.
Bye.
Bye. Thank you so much.